Hey, how you doing? I've got a very cool bass on the bench today. It's a mid-70s Fender Jazz. Done a bit of setup work on it. The machine heads needed a bit of love. There was a few loose frets. The main job I was asked to do though was to rewire the control plate, and that's because, well, there was some pretty dodgy soldering in there. And I'm just about to reconnect the pickups to the volume pots, but I've decided to do, well, a little bit of a mod to the pickups, and that's because when you touch the pole pieces, yeah, you get a pretty nasty buzz through your amp. Now, that buzz is not from 50 hertz hum or single coil hum or 60 hertz, I guess, depending on where you live. It's actually something quite a bit different, and in this video I want to demonstrate what's going on, try to explain why it's happening, and I'll show you a whole bunch of different ways you can remedy the problem. I've already chosen the way I'm going to do it, and it's probably not what you think. So let's get into it. So if you've ever plugged a lead into your amp and then gone and touched the tip, you always get that loud hum. It's a similar sort of buzz to what you hear in this situation with the pickups. And the reason it's happening is simply because our bodies conduct electricity, and in this case, because I'm not touching anything, I've got shoes on, I'm not touching the concrete, I'm not touching any part of the amp or anything like that. My body is electrically kind of floating, and it's essentially acting like an antenna, or a receiving antenna anyway, and all of the electrical interference that my body's picking up, I'm just injecting that straight into the input of the amp, because the tip is the signal input of the amp. The sleeve is the earth. And because our amp is, has a high input impedance and it has a ton of gain, even though these voltages are tiny, it's actually a pretty loud buzz. So this is a test lead. I've just got alligator clips. The red one is connected to the tip and the black one is connected to the sleeve or earth. And I am going to hook up this pickup. The white wire was the hot wire, and I'll hook that up to the tip. The black wire is the earth wire or ground wire. Hook that up to the sleeve. And yeah, when I plug that in, when I touch the pole pieces, there's our buzz. Now, the thing is though, with this guy, I was actually directly touching that tip. But the thing about a pickup is that these pole pieces are not actually touching the coil. In fact, we can even test it with a multimeter. If you set it to resistance, it should be open circuit. I'll just hook up one probe to the white wire, and again with these magnets, obviously there's our tiny amount of resistance if I short those two probes, but with the magnets it's open circuit and there's no measurable ohmic connection, even a really large resistance. Let me try the other wire. So yeah, between the magnets and the coil itself, there shouldn't be any measurable resistance. In fact, if you do measure some kind of resistance, even quite a large resistance between those two, then realistically it means that your pickup needs rewinding, I'm afraid. If we actually look at an unwound Fender Jazz pickup bobbin, I'll turn that off. What we have here is a row of magnets like that, and when you go to wind it, you connect this stuff, which is our winding wire. It's very, very fine wire, to one of these eyelets, and then you wrap it round, thousands of times, and then you connect the other end to the other solder eyelet, and then of course you solder your two leads up to it. And in this case, you have one wire that's connected to the hot or tip in this case, and the other wire is connected to earth or the sleeve of my test lead. Now, when you wind a pickup, what most pickup makers do these days is they'll actually wrap the magnets with a layer of insulating tape, and then the wire itself, even though you can't see it with the naked eye, this has a very fine layer of insulation on it as well. And again, I can test that with my resistance. Again, we're getting, if I can somehow manage to test that between two pieces of this wire, again, we have an open circuit. So the wire is actually insulated. So what that means is that the wire itself and the magnets are separated by two types of insulation, a layer of tape and the insulation on the wire. With old Fender pickups, they didn't bother taping the magnets, or at least I don't believe so. They actually just sprayed them with some shellac or some lacquer of some sort. In fact, you can still see on the bottoms of these, you can still see some of the yellow. I believe that's what it was, a bit of yellow sort of lacquer or shellac or something. So even though those two forms of insulation are very, very thin, yeah, the wires aren't actually touching. So why is it still humming when I touch the magnets, even though I'm not literally touching the tip of my plug? Well, the reason is that between the magnets and the coil, there's a whole ton of capacitance. So if we actually get a capacitor, this is a nice bright orange capacitor. Again, there's no ohmic connection between the two wires. You can see that's just an open circuit. However, if I connect that to the test lead, same deal. Even though I'm not actually ohmically connected to the tip, I'm actually going through a capacitor, I still get that buzz. And that's because a capacitor blocks DC, but it passes AC. And a signal is AC. Signal from your strings into your pickup and out of your bass is AC. All audio signals are AC. And the signal from my body, when it's unfortunately acting as an antenna, is also an alternating current. It's an AC. Now, if you look at one of these really old school ceramic disc capacitors, you can almost see how they work. There's actually two metal discs, and you can kind of tell that one of these leads is connected to one disc and the other lead is connected to the other disc. And those two discs are very close, but they're actually separated ever so slightly by an insulating material which is known as a dielectric. And it's from that type of capacitor that we actually get the symbol for a capacitor, which is supposed to be two plates and then our two wires. Of course, there's lots of different ways to make a capacitor, and I would think in this one that's probably two pieces of foil all wrapped up together and rolled up together, or some other arrangement, but there's two conductors in there that are very, very close but not quite touching. And it's obviously the same thing going on with our pickup. We've got this magnet wire wrapped around very, very tightly and many times over the magnets. And even though they're insulated, we've got two conductors that are very, very close, but isolated from one another. And that's why the signal can pass from the magnets into the coil. And depending on your multimeter, let me turn this back on. Depending on sort of how it tests capacitance, you can actually kind of measure this. So if I connect one probe to the white wire, which is our hot wire, then with the capacitance, I'm getting something around 60 picofarads on that magnet, and on the other outer magnet, something around 20 picofarads. With the intermediate magnets, well, my meter's not sensitive enough to pick up anything there. You've got to understand the outer two magnets, of course, have a great deal more capacitance, and that's because when the wire's wrapped around this guy, obviously it's wrapping around pretty much half the surface of this magnet, whereas with the inner magnets, it's really just brushing by either side. So if I test the other end of the coil, we measured 60 before, and now we're just under half of that at this end, and I think we measured 20 And again, we're just under half that at about 8 or 9 picofarads. So what that's telling me is that it's most likely that the white wire is actually the start of the coil, or the inner wraps, because they're the ones that are wrapped almost directly onto those magnets. So if I take the cover off, I've got to be careful because the pickup's 45 years old. But if I take the covers off, you might even be able to see what I'm talking about. I'll try and zoom in. Not sure if it can tell, but this end, the white wire, if you look carefully at that winding wire, it actually seems to go underneath the coil. So that's why I think it's the start. And if you look at the black wire, well, the winding wire from the black side, if I can get the light there, you can see actually emerges from the outside of the coil. So again, our capacitance test has sort of confirmed what we thought, and that the black wire is the end of the coil and the white wire is the start of the coil. So if we go back to the start and I've got my lead plugged into the amp, again, there's the buzz. So how do we stop this? Well, it's pretty simple. We just have to hold my body to 0 volts, and all I have to do is just touch earth. So again, the sleeve of the of your jack is connected to earth. So now that I'm touching that, when I touch the tip, because my body's held at 0 volts, it's no longer acting as an antenna. So we can do the same thing with the capacitor. So again, there's our buzz, but if I touch the earth, it goes away. And of course, yes, you're probably already ahead of me, but if I do it with the pickup, it's the same story. There's our buzz, but if I touch earth, it goes away. Now, if you've ever wired up a guitar, you'll know that there's almost always a wire running from earth to underneath the bridge to connect the bridge to earth. And you might be saying, well, that means the strings are connected to earth, and of course whenever you're playing, you're touching the strings and your body is earthed. So why is this a problem? Well, there's quite a few reasons that system doesn't work. Number one, if you're playing an open string, obviously you're not touching the strings, so that can be a problem. What happens with vintage instruments quite frequently is that the connection between that earth wire and the bridge breaks down. With this bass, that was the case. The wire is normally just frayed out, and then they screw the bridge down on top of it, and over time that wire sort of tarnishes. This bass is 45 years old or something like that, and also the bottom of this bridge, or the bottom of the tailpiece, was really quite corroded. I actually had to rub it all back and then coat it with penetrol to sort of stop that rust in its tracks. And also, when I reinstalled the wire, I've actually used quite a large piece of copper foil, and that means, well, it means I've got a large surface area, which is a much more reliable contact, but I can also solder the wire to that as well. But I think the main reason this has been a problem, especially it seems to come up on TalkBass quite frequently, and especially in the last 10 or 15 years, the main reason is that people are using coated strings, like elixirs. I actually really love elixirs, and I've got them on several of my instruments. At Mayton, when I worked there, we used to put elixirs on all of the instruments heading out the door. They're fantastic strings, don't get me wrong, but of course the coating on the strings does sort of also electrically isolate your body from the strings. So that's another thing to think about, and I think it's one of the main reasons that this happens and comes up as a topic on forums like TalkBass. And of course that goes with any coated strings, like tape wounds and stuff as well. Now, luckily there's loads of ways you can remedy the problem. The first one is simply to connect the pole pieces to earth. And the way that most pickup makers do that is with a piece of this stuff, some copper shielding tape or copper foil. You can buy this with a conductive adhesive, and you run a strip of that, and then you can solder an earth wire to that. There's a couple of problems with that though. First is that over time, in my experience, for whatever reason, the adhesive in this stuff sort of breaks down or builds resistance or something. And I've had loads of bass guitars and guitars come through that supposedly have earthed pole pieces, and you flip the magnets over, you flip the pickup over, and there's a piece of copper foil there. But when I measure it, I'm getting no continuity between those two. So I assume it's just because, yeah, the adhesive is sort of somehow broken down over time. So what I normally do, if I have to do it that way, I actually put a piece of copper tape over half of the magnets, and then I use a little drop of this stuff, which is called wire glue. This is a water-based conductive adhesive, and I put a little drop of that on each magnet, so it overlaps between the magnet and the copper tape. And that gives me a really nice, long-lasting and reliable connection between the magnets and that piece of foil, which of course I can solder to earth. But for these pickups, I'm not going to do it that way. And, well, that may be obvious, especially if you've worked on vintage instruments. I mean, the bottoms of these pickups have all sorts of stuff going on. There's a date stamp or a serial number. There's this old yellow lacquer that I was talking about. There's sort of remnants of the foam or whatever is there. And for me to use wire glue on them, I'd have to get in there with solvents and clean all the bottom of the magnets. And with something like a 45-year-old original Fender pickup, that's not a good idea, because you'll be removing part of the history of the pickup, so part of the provenance of the instrument as well. Even sort of beaten up, refinished jazz basses like this beautiful old guy, these are getting quite valuable these days. And those pickups, the more you can keep them original, the better. The other problem with connecting all of these pole pieces to earth comes back to this guy, the capacitor. Remember that this white wire is the start of our pickup coil. So we've got our pickup coil, and the white wire is our hot wire, and the black wire is just connected to earth. So between the start of the coil, where the white wire is, and these magnets is a capacitor on each magnet. So essentially we have a capacitor like that, and we've got 8 of them times 8. So if we go ahead and connect all of these magnets, which is sort of the other side of our capacitor, we connect them all to earth, then all of these capacitances are in parallel, and that means they add up. And, well, it might add up to, I don't know, 100 picofarads, maybe more. And that may be enough for you to actually hear a difference in the sound of your instrument. It may actually dull the tone or change the tone of your instrument. It's not really changing the pickup. What it's doing is it's kind of lowering the resonant frequency of the kind of tuned circuit or the resonant circuit that is made up by your pickup, your pots, and the capacitance of your guitar lead. But yeah, it may actually change the tone of your instrument. Now, of course, there's a lot of variables involved in all of this: the strings you use, the type of playing you do, your rig, whether or not you have an onboard preamp. So there's every chance that by earthing the pole pieces, you won't hear a difference at all in tone, but it is something to keep in mind. Another thing that a lot of guys try is just painting some varnish or nail polish or something on top of the pole pieces. And that sort of stops or isolates or insulates, I guess, the pole piece from your body. And to be honest, I don't know how long that lasts. I reckon if you're like me and you rest your finger on the string and it's sort of touching that pole piece, I think it would pretty quickly wear through. But you're welcome to give that a go. The other option is, of course, to replace the covers with ones that don't have holes in them, and that works really well as well. If you do that, what you want to do is put some shimming material on either side of these proud pole pieces, because otherwise when you press the cover down, you can actually distort the top of it. For obvious reasons, I'm not going to do that with these. It would look kind of a bit out of place on a vintage instrument. So what I am going to do is I'm actually going to reverse my black and white wires. In other words, I'm going to connect the white wire, which is the start of the coil, to the earth side of the circuit, and I'm going to connect the black wire, the end of the coil, to the hot side of the circuit. Buzz, buzz, buzz. So now I'll swap these wires over, and I've got the white wire connected to earth, and I'll use the black wire now as my hot wire. And now when I touch the magnets, there's no noise at all. And that's because the capacitive coupling is between the magnets and the inner windings, which is the white wire. Well, any noise or any interference picked up my body is just shunted straight via that white wire to earth. Now, obviously, when you swap the hot and earth wires on a pickup, you're also reversing the phase of the signal from that pickup. So what that means is that I also have to do the same mod with the neck pickup. Otherwise, when I turn the two volumes up, well, the signals will be out of phase and the bass will sound terrible. Luckily though, Fender Jazz Basses actually have pairs of coils that hum cancel with each other. So not only are they reverse magnetically, so one's a north coil, one's a south, they're also wound in opposite directions. So what that means is that when I reverse this so that it's back in phase with the bridge pickup, I'll end up with the white wire connected to earth, and it is also the start of this coil. So that means these pole pieces will be nice and quiet when you touch them. But it's not always the case, and sometimes you have to just kind of make a judgment call and make the best decision for the instrument you're wiring. So this is one of my basses. I use it as kind of a test bass for different pickups and preamp designs. And right now I've got a very cheap and cheerful Stingray style pickup. This is Chinese made. I think it's an R-Tech. And like the Fender Jazz, it does hum cancel. We've got two coils wired in parallel, and we've got a sort of a north coil and a south coil. But unlike the Fender Jazz, both coils are wound in the same direction. So what that means is that for me to wire the pickup so that the signal from both coils is in phase, you end up with one coil, the start of one coil or the inner windings wired to earth, and on the other coil you end up with the end of the coil or the outer windings wired to earth. So what that means is that no matter how you wire this pickup, you always end up with one set of quiet pole pieces and one set of pole pieces that buzz. Now, the problem of noisy pole pieces isn't just limited to vintage jazz basses and cheap Stingray pickups. You often have to deal with it in custom wiring setups where you're using two pickups from two different manufacturers. And that's because there's no real industry standard for winding pickup coils. And on top of that, depending on the pickup design, often there won't really be an option for adding an earth wire to pole pieces because you'd end up having to disassemble the bobbin or remove potting or whatever. So sometimes you just have to find the best compromise and wire the instrument so that the pickup with the noisy pole pieces is in the position so that you're less likely to touch it with your particular playing technique. In an old video with this bass actually, but with another pickup, I ended up soldering a wire to the tops of all of the pole pieces underneath the cover. It's a fairly extreme mod, and the current pickup has alnicos, so you can't solder to them. So I think with this one I'll probably just use the copper tape and wire glue trick. The other time that you come across this issue is when coils are wired in series, and of course the most popular bass with series coils is the Fender P bass. So when two coils reverse wound are wired in series, you have the end of one coil connected to the start of the other, and this is hot and this guy is connected to earth. So obviously only one coil is actually connected to earth. So when I wire a P bass, I usually have it so that the coil under the E and A strings is the quiet one, and that means that the coil under the D and G is the one that buzzes a bit. And that's because, like most bass players, I rest my thumb on the pickup and then I often move it over to the E string where it's very likely to brush this pole piece right here. This bass has elixirs on it as well. Yeah, well, those pole pieces seem pretty quiet now. Just makes you wonder why Fender don't just wire it that way in the first place. Anyway, I hope the videos shed a bit of light on yet another type of interference that your guitar circuit can pick up and send off to your amplifier. If you did enjoy the video, please like and subscribe and hit the bell. I really appreciate all of those things. Thanks for watching. I'll see you in the next one.